All right, we have a rocket question. And when I skim through this, all of this looks like motion. There's not a single thing related to force here. And so let me just get my equations written down. So I see no forces or energy at all mentioned. So no F, no kinetic energy. So just what we call motion or kinematics. That's the equations we're dealing with. And let me go ahead and write those equations down. So we're going to have S is 1/2 AT squared plus UT. V equals AT plus U. And V squared equals U squared plus 2 times A times S. Perfect. Now, it says sketch a graph of how the velocity changes. So we have this rocket going for 5 seconds upwards at this acceleration. Then it continues to go a little bit higher up, and then it falls to the ground. So let's just kind of sketch what's going on. So the velocity in meters per second as a function of time in seconds. So first, we go up into the air, and this is at time t1. And then what's going to happen is the fuel's going to cut out, and then it's going to slow down to stop at the top, and then it's going to fall back to the ground, gaining speed as it falls. So one thing I want to say, this is a little bit of overkill. I don't think the IB requires this, but I'm just going to be clear. The slope here is 8 meters per second squared, and the slope here is negative 10 meters per second squared because of the acceleration due to gravity. And it says comment the area under the graph you've drawn. So let's be clear. The area that they're talking about is we have this area here, and we have this area here. So I'll call this area area 2. I'll call this area area 1. And remember, the area is the displacement when you look at a velocity graph. So A1 actually equals A2. In other words, the distance up equals the distance going down is the idea. So let's actually write that up in our answer down at the bottom. So the positive area equals the negative area because the total displacement is 0. It launched and landed in the same place. And that's the idea. So, don't like these notifications. So there we go. So we're launching and landing in the same place. Now, we want to get the speed of the rocket when the fuel runs out. So now we're just going to jump in and use our formula. So V equals AT plus U. So V equals 8 times 5 plus an initial speed of 0, which is 40 meters per second. It says the height that the rocket reaches just when the fuel is run out. So let's try this. S is 1/2 AT squared plus U. So that's S is 1/2 times 8 times 5 squared plus 0, which is going to be 4 times 25, which is 100 meters. And then the maximum height reached by the rocket. So let's be clear. Let's get an S extra in addition to this S here. And that's going to be 1/2 times negative 10 times t squared plus 40 times t. So that's not going to work. Not a good idea. I tried. So I wanted to see, I didn't deliberately do that. I just thought that might get me the answer, but it's not going to. So I'm going to move on to the next formula. Let's try this one. V squared is U squared plus 2 times A times S extra. So V squared at the top is 0. U squared is this 40 meters per second right when the fuel cuts out, plus 2 times negative 10 times S extra. And so we're going to get that 1600 equals negative 20 times S extra. And so we're going to end up getting 80 meters is that extra height. So the total is going to be 100 plus the 80. So what I did is, right when the fuel cuts out, it speeds 40, and I use that to get the additional height that it achieves. So I took 100 plus 80 to get 180 meters. Now the time to reach the maximum height, that's going to be the 5 seconds plus the extra time. So let's figure that out. So you've got V equals U plus AT, and that 0 equals 40 times the unknown time. You know, this is not even right. Let's see. V equals AT plus U. Sorry about that. So we reach a speed of 0 at the very, very top, and we temporarily stop before falling to the ground. And negative 10 is the acceleration, because that's gravity, times the unknown time, plus the 40 that we start with. So t is going to be 4 seconds. So the total time is going to be 5 plus 4, which is 9 seconds. Now let's get the time it takes to fall from the maximum height to the ground. So we know S is 1/2 AT squared plus UT. We're falling, so our initial starting speed is 0. We're falling from rest. We started at a height of 180. It's going to be 1/2 times 10 times t squared. So we're end up getting 36 is t squared. So t ends up being 6 seconds to fall back down to the ground. So that is question number 12.